Hello everyone, this is Alfio Sendo. Today we'll talk about Leetcode 675 cutoff tree for golf event. If you like my videos, please help me by subscribing my channels. You can find the complete code for these problems and all the video lists in video description below. Let's look at problem first. So we are given a matrix and if there is zero means the cells cannot be walked through. If there's one, it means we can walk through. Also, we will have a number greater than one. So that means we can also be walked through, and these numbers we need to be cut off to one. Another requirement is that you must cut off the tree in order from shortest to tallest. But it doesn't mean we cannot work through if the tree is not being cut off. So we also guarantee that no two trees have the same height, and at least one tree needs to be cut off, which means we can always expect a solution not blocked by the height. It can be blocked by zero, but it's not possible to block by the same height of two trees. Here we're giving examples. So the minimum steps when you cut off the tree is we go through this path 1, 2, 3, 4, 5, 6, 7. Okay, next let's take a look at how we solve these problems. Before talking about the complete solution, I want to talk about the sub problem first. So for examples, we are given this matrix. We only have two trees need to be cut off, which is 1 and 2. So actually 1 is not the tree we need to cut off. So we only need to cut off 2, but we will start with the 1 here. So that's very straightforward, right? So to obtain the minimum step from the start point and to cut off the tree 2, we can use the breadth search. So in code below, I show the regular BA-face template. So we will open a queue to store the current visited position. Then we have directions to help us to looking up, down, left, and right. We also have a visited 2D matrix to help us to store the index we have already been visited. So here I use a 2D array since we have X and Y positions. You also can consider to use unordered map, but you need to encode the 2D position to 1 to be able to use the unordered map. For the pair of the positions, you also can use ordered map, but that will require the extra element insertion times. Then after we all have all those scope variables, we have two while loops, one by one. Then we store the current levels element size. Then we use these two as a end condition for the second while loop. So this can help us to save a one queue. So in another way to implement buffer search, we have two queue. But in this way, if we store the current levels size, we can reduce to use only one queue. Then in this while loops, we have a for loops. Basically, we search for current elements up, down, left, and right. Then to choose the selected elements. If we find the current cells equal to the target, we will do the early exit. Okay, now let's take this example and see how these templates work. So at first we start with 0 to 0. It was initially being pushed into queue, but here when we got the XY here, the queue we will pop the queues afterwards. So also be careful here. We need to do a auto copy here, not auto reference, since we will change the front elements in the queue. If we use a reference here, it will be generate a problem here. So be careful here. It should be a constant auto copy. Now let's get back to the our explanations. Then when you're looking for the up, left, right, left of 0, 0. Then first we take a look of the right one. So right one is the select one, of course. We put the select one into the visited cells, and also put the right one in the queue. Also, we'll look at the lower one. It's 1, 0 here. It's also select one. So we push to the visited as well. So this is our current two size queue. Since our last layer's queue only have one size, which is 0, 0, so now we need to increase the step because we have finished this queue, finish this while loop. So we increment the step. So in the next step, also next level, we pop the 1, 0. Sorry, we pop the 0, 1 first. So there's only 1 0 existing in the queue. Then what happens is it will look 0.01 right, left, and down. So its down element is 0, so it's not being selected. So its left one is already visited, so which is cannot pass this condition. So the only elements we can add is right one. So here we add its right one. So right one also need to be pushed into the visited 2D matrix. So we have done the neighbor of the 1, 0. Oh, sorry, 0, 1. So next, that will be the 1, 0. We will pop the 1, 0, and there's only 0, 2 in the queue. We're looking for the neighbors for 1, 0. Its up elements has been visited, and its down and right is 0, cannot be walked through. So there's no qualified select elements among the label of the 1, 0. So here we have done the second layer. So 0.2 is the third layers. Then here 0.2 enables only 1, 2 qualify our requirement. We push 1, 2 in our queue, also in the visited. Then our third layers has also been visited here because there's only one element. So our fourth layer is 1, 2, which is meet our requirements to meet the target. We already stop here, return the step. So the layer basically means how many steps we can achieve for the target node from the initial node. So then we are basically finishing all the breadth search process and find the target node in the minimum step here. Okay, so how these subproblems relate to our main problems? So basically, from the observation, we can use divide and conquer for the problems. So if we can sort all the trees heights in a vector, then we can do a breadth search for the every two elements in the sort list as follows. So given the examples here, 1, 3, 2, 4. So we want to go from 1 to 2 first, because after sort is 1, 2, 3, 4, right? So we want to go 1 to 2 first. Then basically we want to solve a breadth search from 1 to 2. We can walk through 3, it's no problem. So after we arrive 2, so 2 we've been cut off and turned to 1. So next we need to go to 3. So it's another breadth search problems. So next step, 3 will be cut off to 1. Then we go to next slot will be 4. So it's from here to 4 here. It's take 2 steps. Now let's see how we can implement this idea. So here we initialize a list will be sorted. We will iterate all the elements in the given 2D matrix. If that cell is greater than 1, we push back into our sort list. So we will sort from the lowest to highest. Then for each element in the sort list, we will put the current element's position as a target. We will start from the 0, 0 as our current cells. Then we do the BFAs for current cells to the target cells and accumulate the steps. If steps more than 0, which means we cannot find a path from current to target, so we directly return -1. After we get the step for these breadth problems, we accumulate in the total step, and we update the forest target as 1, and we update the current one with using the target 1. Eventually, we will return the total step. So basically here we use divide and conquer to split the whole problems into several sub-problems, then solve one by one, basically using the same approach. So here is the runtime and the memory time of my solution. These problems among all the submissions. The computation time. So each BFAs, at most we will travel m multiply n. If m is the width of the matrix, n is the height of the matrix. And most it will travel m multiply n cells. And also, if we want to cut off tree, right? So if we want to cut all of the trees in the matrix, so it's another m multiply n. So computation is m multiply n multiply m multiply n. Also, you can write it as m square multiply n square. For the space complexity, we are using a sorted array list to store the sorted meta information. Then it's a matrix, right? So it's take a big of all of m multiply n. Okay, so that's all I want to talk today. Hope you like my video. Please feel free to add comments and suggestions below videos. See you in next video. Bye.